this test is for independent two-sample testing for means. Today is 4/9. Okay, now there's many different types of two-sample testing, which we will go over eventually all the different types. But there's independent and dependent samples. Independent is where the sample from one population isn't related to a sample from the other. For dependent samples are also called paired samples. It's where the sample from one population is directly related to a sample from the other. In fact, so much so that they are paired together. Okay. So, for example, let's say that we were looking at like the height of a boy and the height of his dad. We're not assuming that these things are related to each other, as in like one definitely affects the other, more that one is connected to the other. So like, for example, let's say I had a whole bunch of like, I had a sample and it's all these heights, right? So imagine I've got like a bag with a whole bunch of papers in it that have numbers that are heights, and they're like all the heights of all the boys at the school. And then I have another bag that has all the heights of all of their dads, okay? If I grab this person, this dad, and this boy, and they're not related to each other, then it makes no sense to compare them, right? But otherwise I could say, okay, this boy and his own father, we're gonna compare the height of him and his father, right? Because those are a pair. They're paired samples. Another example would if I said the heights of girls versus the heights of boys. I mean, I could have 10 girls and 10 boys and directly say what the height of each one is, but it wouldn't make any sense to compare them to each other, because why would I put Natalie and Noah together? You know, like why would I put Georgia and Noah together? There's no real reason to. So independent looks like this. You basically have two samples. Here's sample 1, here's sample 2. Maybe this one has a few data points in it, and this one has a few data points. They don't have to be the same number of data points when they're independent. You could have, this sample has 5 in it, this sample has 8 in it, doesn't matter. Oh, no wonder you're not drawing. I was like, everybody seems really confident on this one. Nobody's even writing anything down. They're just like, yeah, we get it. I'm like, wow. Can you move the camera? Okay, yeah. If two things are dependent, they also look like chocolate chip cookies. Only this time, these pairs are related to each other. So I would have like 2 chocolate chip cookies here with 4 people in each, 4 samples. This is sample 1, this is sample 2, but it's like they have a pair in the other one. A really good example of dependent pairings is before and afters. It's not always a before and after, but it's often a before and after. Did this running shoe make you faster? Did this exercise make you thinner? Did whatever, this prep course for the ACT give you a higher ACT score? So you would test your before score and your after score. Paired. All right. Independent or dependent? Let's have you guys do it, and I'll give you prizes for it. Height of 27 adult females, heights of 27 adult males. Independent or dependent? Independent. Just because they're both 27 doesn't mean that they're related. Midterm exam scores of 14 chemistry students, final exam scores of the same 14 chemistry students.
I'm pretty sure the answer is dependent, but I think you could make an argument that it's independent.
It's not whether one affects the other necessarily, it's whether it's one-to-one. So like, if I said, okay, I've got these 14 chemistry students, midterms, and their 14 final exams, and I say, here's Noah's midterm, which one should I compare it to? I'm gonna pick Noah's final exam. I might do the analysis and find out, oh, just because you did well on this one doesn't mean you do well on that one. So I still can compare and analyze those information together, but they have to be paired. So this one is paired, that's why it's dependent. So when I say they're related to each other in some way, I mean like they're the same chemistry student. Not that just because you did well in the midterm means you'll do well in the final. Okay, so that was Georgia and Noah. Go get prizes. If you grab a sticker, make sure you put it on your folder. It's required. A freshman today got one of Nathan's stickers for his business and was like, what is this? I was like, it's just a 3D printing business that I like to promote. They're like, you're giving away like advertisement stickers? And I was like, sure.
Dang, now I kind of want one of Nathan's. I had one on my Bonneville, and I had to put it to scratch, so I need a new bumper sticker. I don't think I got Nathan's. Aw.
I'm struggling to peel this. Hold on.
Is it alright if I put mine on my laptop?
Yes. What did you get?
Be patient, but it's a storm cloud.
It's a weird message. Hey, be patient.
Look at that.
But it's a crying storm cloud.
Be patient. It's fine. Just be patient. All right.
Actually, I'm not being patient right now.
See, that's why it's crying, is because it wasn't patient.
Mm-hmm. Do you want me to help you with your sticker?
I'm being patient.
Okay.
What is your matter?
While you're being patient, you're gonna be so patient. All right. So let's talk about steps. First step when you do a 2-sample test is that you have to verify that both population standard deviations are known. Because otherwise we're going to do a t-test, not a z-test. This is a 2-sample z-test. Okay. This is in the problem. Then you write your null and alternative.